Hi, why should you take a course on serverless machine learning? Most machine learning models never make it to production. For a model to make it to production, this means that some service, product, application, or user interface is going to use the model to help it make intelligent decisions or predictions. Now, for a model to be truly useful, it's going to work with new data. You'll have new data always arriving. The model will keep making predictions with it, and it'll keep adding value. Now, many people think that in order to build this prediction service around your model, you need to be some kind of expert in Kubernetes or Docker or cloud infrastructure, because it's really challenging to configure and install all the infrastructure you need to make your model shine. Now, in this course, you're going to learn how to build and operate prediction services that build on your machine learning models to make intelligent decisions. And you're not going to have to learn all of the infrastructure you may believe you need to build a prediction service. And the reason why you won't need to build all the infrastructure is because we're going to use what we call serverless infrastructure. So serverless infrastructure is services running over the internet that you can use without having to install, configure, operate, or manage that infrastructure. And it's often synonymous with the cloud. So people think of the cloud as a way where your applications can be easily made elastic or highly available. They'll be backed up, upgraded, restored, and you only pay per use. This is the kind of infrastructure that we're looking at. So really cloud native serverless platforms. Now, this course is different because in contrast to many existing machine learning courses, we're going to work with continuous data flows. You're going to learn how to take that data, that raw data, and build features out of it. Those features may do things like extract some specific information from a larger data set. Maybe it'll compute aggregations. Maybe it'll use dimensionality reduction to compress your data, or you're going to transform data into a numerical format that's going to be conducive for models performing well in terms of learning. Now, it is the first MLOps course that only has Python as a prerequisite. We don't require that you need to learn Kubernetes, Docker, or any of those infrastructural services that you may believe are needed. You will learn to build complete serverless prediction services. It's not a modeling course. We're not going to go into the details of how to tune your hyperparameters and decide on your model architectures, but what we will do is we'll enable you to demonstrate the value of the models that you build to stakeholders, people who want to use the models, people who are maybe supplying data to the models or helping you deploy those models in production. You'll be able to give them a realistic view of what this model will offer in the service by embedding it in this real system. And we're going to learn the principles of MLOps. So principles include things like versioning your assets, your features, your models, testing them to make sure you can build systems that rely on these models, validating them. And also when the system is running, we want to monitor and upgrade both the features and models that make up your systems. So the assumptions in this course are quite different to existing machine learning courses. We're not going to deal with static data sets. The data you get won't always be 100% correct and unbiased and come from a single URL. And we're not going to just evaluate your model with a single metric like accuracy. So what we do assume in this platform is we're going to work with systems where data never stops coming. And that data may come from more than one source, maybe heterogeneous data sources, so data warehouses, maybe from REST APIs or even scraping data from the internet. We're going to use Python in this course, and we're going to use Python to build both our machine learning models, to extract the features, and we're going to also use it to deploy the models and even build the UIs. So we will enable you to communicate the value of your models with a UI. Primarily we'll be using Python and HTML for that. And then we're going to also deploy and operate these prediction services using the best practices of machine learning operations, as I mentioned already. That means versioning and automated testing. So what are examples of non-stop data? So data that just keeps coming. So if you've worked on an e-commerce website, or if you've used one, which many people have, you'll know that new data is constantly coming. People are purchasing items, people are logging onto the page, people are searching, clicking items that are recommended to them. You can use that information to help obviously get a better picture of your customer, and not necessarily training a new model, but building new features that are very fresh about what the customer has clicked on recently, bought recently, or maybe selected or not selected when you recommended a product to the customer. Now, there's many other systems related to marketing, like customer 360 systems, where you have a picture of your customer, a 360-degree picture of your customer, and new data is always coming in from your customer. Maybe your customer is contacting you by email or clicking on your website or using some service that you provide. But to bring all that data together, it's going to keep arriving. It'll never stop until your company maybe one day stops. Now, credit card payments, of course, as a service, we're going to cover it as a tutorial and example in the course. We're going to look at fraud for credit card payments, and credit card data is flowing the whole time because people are using their credit cards. They're performing transactions. They're transferring money. We're going to look at other services that are slightly different. You might consider more serverless machine learning services for society, like air quality. Air quality information is available all over the internet now. You can get live data and historical data from many different locations globally. So, to build a prediction service might be something like, let's use weather data to predict air quality. It's not out there today, so why don't you be the first person to build it? Electricity prices are a really hot topic in many Western countries these days. So being able to predict electricity prices might be something that excites people. Even doing things like predicting the aurora borealis, it's not something that you can go on the internet and find today. So we'll hopefully inspire you to solve problems like this and problems like predicting the height of waves at beaches based on the open ocean swell forecast. So these are some of the services. Some of them we built and some of them were just ideas. I hope to inspire you to maybe come up with your own ideas for prediction services. So the data for these prediction services is going to come from many different heterogeneous sources. We'll work a lot with tabular data in this course, so you can think of it as being, the credit card fraud example I mentioned earlier. There's transactions coming in on credit cards, there's customer profiles, there's credit card profiles. This is all in tables and databases. But many other sources include unstructured data for images, sound, and video. You can have logs arriving from your services, and maybe they're stored in a free text search database like Elastic. You can have objects in JSON in a MongoDB database. You can have graph data in Neo4j, time series data, event data in Kafka, and you can have third-party services like Salesforce and HubSpot that provide REST APIs where you can use that data again to build prediction services. And then if you're looking at just building kind of user-facing applications, there's a lot of data out in the web because society has digitalized and that data is available live. So we should be building more of these prediction services around that data. Now, much of the data that you'll see, it won't be in the kind of pre-made format that you may be used to from other machine learning courses. We're going to have to take that raw data and create features from it. And in many existing courses, the kind of advice that you get for how to create features is something like this owl drawing advice. Draw some circles and then draw the rest of the bloody owl. So, that's kind of not so helpful. We need more details and more a potential for learning the techniques that are available for creating features. So we look at things like aggregation. So an aggregation might be that what is the weekly vacancy level on a given room in a hotel, given that the raw data I have are just the individual bookings. Maybe I have user activity history in a website over a long period of time, but it's too much data to feed into the model as many different features, so I can compress that using something like an embedding. Maybe I have some data about the user's date of birth, but it's too sparse to be able to use this to train a model. So if I extract the feature of the user's age band, so between the ages of 18 and 35 or over 65, that becomes a categorical feature which can be quite easily used to train models with. If you've got numerical data, you might want to normalize those numerical features because you're using a modeling technique based on gradient descent. Or maybe if you have categorical features, you might want to use something like one-hot encoding. So we'll look at many of these different techniques for feature engineering in the course. Now, you will want to communicate the value of your model. That's one of the big things that hopefully will come out of this course, that you learn how to take a model and just build a simple UI on it. So that some of the frameworks that are out there today, things like Gradio, GitHub Pages, Streamlit, they enable you to really just, with Python or some simple HTML, be able to take the output of your Jupyter notebooks and put them in a format that's either interactive or as a dashboard. And this really can help communicate the value of your model to stakeholders who maybe aren't really so excited by an accuracy or a performance measure on your model, but would like to see how that model will transform a service that they already provide. We're going to follow principles of MLOps, and to put a little bit more meat on the bone here, some of the assets that we want to build when we're building these prediction services are not just the models, but also the features that are reused in many different training data sets. And all of these assets need to be versioned. We want to do A/B testing for them. We also need to ensure that they're of very high quality. This means testing. So there are techniques like data validation with great expectations, unit testing of feature logic, pipeline integration tests, again with PyTest. We'll use PyTest in the course. And then also evaluating models for things like bias and automating these testing processes so you don't have to run them manually by hand. There's a little bit of software engineering for those of you with a heavy Python or maybe not as a strong software engineering background, but I think it'll help enormously. So what we hope to give you all together are new capabilities, new superpowers, if you will. In many organizations, data scientists are kind of stuck in this this walled environment where they get dumps of data. Particularly in large companies, they'll get a dump of data from an analytics team, they'll hand a model over to an operations team, and really this makes it very hard for data scientists to own the process end to end. What we want to help you achieve in this course is to enable you to be responsible for the success of your models end to end, from the data that comes in, the features that are created from it, to training the models and deploying those models as prediction services, as part of a service that will give a user interface and some sort of interactive or dashboard or analytical understanding of the predictions that the model is making. So we want you to not just train models, but to build prediction services. And you want to, these services that you build, the models that you train, we want you to be able to evaluate them and debug them in their natural habitat, which is in the services that they transform. So I'm really looking forward to giving this course, and I really hope that you find it not just a useful and interesting course, but it helps give you new skills that will enable you to bring your models to a higher level and help them shine. Thanks.